So we should be live. So welcome everyone. This is the Quant University AI Spring School. Most people who have been attending these guest lecture series know that we have been meeting for the past couple of years. Primarily every Tuesday we meet and we bring in an expert guest speaker who has been working in the intersection of AI and finance. And we talk about various topics on which is contextual and also which has had multiple developments in the past few years. Now, Quant University, as you all know, is an organization we set up 10 years ago, primarily to help financial professionals bridge the gap between all these frontier technologies and applications to both quants and financial services professionals. And we have seen the evolution of the technology stack. We started with big data and analytics, and as we saw the influence of machine learning models and now large language models, we have seen a significant progression in the complexity and also the diversity of the various kinds of models which are being used in the financial services enterprise. And with that realm, we are trying to bridge this knowledge gap by providing both upskilling and cross-skilling training programs for financial professionals. And also we host these guest lecture series to help share some of the best practices which professionals and researchers are seeing through their work and also through their practice within their enterprises. With that, I would like to invite Dr. Dagesh Mehta, who heads applied machine learning research at BlackRock. I've heard Dagesh speak on various forums, and also he has many talks which has been recorded and available on YouTube. He's a highly accomplished technical professional, but also now he's been heading applied machine learning research at BlackRock. And recently he shared a paper on how to choose a threshold for LLM evaluation metrics on LinkedIn, and I read the paper and I thought this is something every financial professional who has been thinking about using AI and machine learning within the enterprise should be aware of. I also know, many other efforts are happening both from a vendor perspective. You have a lot of companies putting together various benchmarks and also best practices, but also in the financial services world, we have heard speakers like Augusto Gianto, who has also presented some of his work on leveraging LLMs and also how do we evaluate these different kinds of models. So with that said, welcome Dagesh. I would love to kind of hear about your work and your work, and we will use the last 10 to 15 minutes for Q&A, and the stage is yours. Welcome.
Sure. So hope you can see my screen and
not full screen mode yet. Yeah, perfect.
Okay.
We can see the full screen mode.
And by the way, I cannot see you guys or nor the questions. So feel free
We are
to
set it up as a webinar.
good.
You can see the attendees. I'll be monitoring all the questions. Oh, before
Perfect.
we get started, people, if you have any questions, please use the Q&A window to put in the questions. We will, if it's very contextual, I'll bring it up. Otherwise, we will hold off till all the presentations are done, and we will have the question answers at the end of it. Thank you.
Yeah, thanks very much for giving me this opportunity to present my work to this kind of audience, which is probably one of the most suitable audiences, I guess, for this work, Shri. So let me start by the obvious disclaimer. All these views are mine, not my company's. This is pure research work. So let's keep it that way only. So the topic is how to choose a threshold for the LLM evaluation matrix. And I'll, of course, expand on all these terms and what I exactly mean by choosing threshold and why do I care about this and so on. But if you have not seen this paper of ours, I strongly recommend you to go to archive and download this paper, and maybe you can read that at your own time. So let me get started. So first, just some level setting so that we are on the same page. I wanted to make sure that we are agreeing on some specific definitions. So first of all, LLMs. LLM is, so large language model is generative AI algorithm. And usually at least these days, is trained on this next word prediction task on the surface of it. So you keep trying to predict the next word in your available text corpus from the entire World Wide Web or entire data of uh, all the text that you can collect. So you try to predict the next word, see if it performed well, then you are good. If not, you might want to adjust the weights. Go to the next word, again, try to compute the probabilities, see if it worked well, not, then you adjust the weight and so on. You do this for the whole data set that you have, and then eventually you have a really good so-called auto-regressive model or next word prediction model. But eventually people realize that just by learning how to predict next word, you have learned a lot of things about the language and probably about also some knowledge that was all in there in the text data. So that was it's kind of a mathematic. All you are trying to do is predict the next word. But while doing that, you learn so many things about the nuances of the language and also some sort of knowledge bank that you have also zipped or captured in this model that you have trained. And then once you train this model, you might not just be interested in doing next word prediction. You might also be interested in doing, I don't know, text summarization and translation and many other question answer systems and so on. So these are called downstream tasks. LLM itself is usually called foundation model. And then all other models that we build as developers outside, I don't know, OpenAI and Claude and Meta and so on, and now DeepSeek, we all are doing some downstream modeling. Usually, an LLM is trained with massive computation effort, so many companies simply cannot afford, or they might not have technical abilities to train their own foundation models. At least that's 1 week ago, that was the situation. With DeepSeek, maybe things might be changing, but we'll see how it goes. So all we can do eventually outside those companies or using foundation model is to do some downstream model or downstream tasks. So one of the downstream task is called information extraction from your internal document. So here the point is that the internal documentation that you have within your form hopefully is not already in the data set that went into this pre-training of the foundation model. So the foundation model does not know anything about your own internal documents. But if you want to still talk to your internal documents, if you still want to extract some information or do some question answers to your internal document using this foundation model, how would you do that? Of course, you can say that you can put the whole document in the prompt in, say, ChatGPT, and then you start asking questions once ChatGPT reads your whole document. That's an obvious idea that one can think of. But the problem is that there is always some limited token window. So you cannot put more than certain number of tokens or certain number of words, loosely speaking. So you have to come up with some other techniques, and leaving many of the historical developments aside, here is probably the most popular techniques to talk to the documents. It's called retrieval augmented generation. And briefly, how it goes is you have your internal document, which is shown here as document in the figure. And then you have some user query or prompt that you put in your LLM. What first you are supposed to do in this retrieval augmented generation method is you rely on some other vector database. So this vector database is some sort of either large language model or so-called traditional models such as BERT, or even TF-IDF and many other word embedding techniques or text embedding techniques. All this vector database does for our purposes is you give some text in and it gives you some vectors out. Okay, that's all this vector database does. So here you put your user query in and you get some vectors out, which corresponds to this user query. You do the same thing for your document. So you put your whole document text into this vector database, and then you get many different vectors out, from which corresponds to your document text. Then what you do is you identify the top k most similar vectors from these document vectors to the vector of this query. So you have, let's say, one vector which corresponds to your query vector or your query. And then you identify top k most similar vectors from your document. Okay, so that's and k might be 4 by default in many of the practical implementations, but it can vary. It can be also a hyperparameter. So once you have these similar vectors or top k most similar vectors, you then transfer these vectors back to text, and then you add the text of the query and the text that came from this top k most similar vectors to this query. And now your bigger query to the LLM or to say GPT or ChatGPT even is not just your original query, but also some text that you retrieved from this document based on this similarity computation. And then you ask LLM this combined question. The point is that this V2, the vectors coming from the internal document, will have some context that are relevant to your internal document, and hence you will get much more accurate answer to your query with respect to your internal documentation. So the answer eventually will be an answer to this combined question. Okay, that's basically the point. This is, of course, very simplistic description of RAG. There are so many more sophisticated developments here. But for our purposes, this is all we need. So let's say you have some RAG system, but then you want to deploy this RAG system in your organization through some chatbot or something. It's not just the questions that you need to worry about, but there are so many other things as well that you might need to worry about. So for example, in this chatbot, of course, in ideal situation, you will expect that the users will ask questions about only your internal documents. But when the chatbot is into the wild, people can ask any type of question. The questions might also have some toxicity, or they might also have some ill, so they might also have adversarial attacks. So specifically meant to break the LLM to start giving some answers that it is not supposed to give. So they are all this prompt injection and jailbreak and adversarial attacks. And you might also, the input might also include some PII that you don't want to have in your system. The user might also start asking questions about completely different topics like medical advice when your chatbot is related to financial services. Or there might also be some specific queries that you are not allowed to take in or even give answer to. For example, people will start asking questions about investment advice. Same for outputs. So once the input query is in, the LLM then gives out answers, but we also need to make sure that the answers also don't have any toxicity or PII or copyrighted information, incorrect answers, and so on. So all these are real problems. You might be hearing some news about many of these issues every now and then, and companies get into trouble with these issues. So, of course, these issues are known to the community, and people have devised many evaluation metrics to measure and hence mitigate some of these issues. I would classify all these evaluation metrics into two categories. So one type of evaluation metrics are called external evaluation metrics. External evaluation metrics are metrics where we require some ground truth labels. Okay. So in traditional machine learning algorithms, we may have all this precision, recall, accuracy, and so on. They require some ground truth label data. So this is what I call external evaluation metrics. Internal evaluation metrics are where we do not require the ground truth label data. So in traditional machine learning, this might be some sort of cluster evaluation metrics such as silhouette score or all this DB index and so on. Okay, so these are internal evaluation metrics. We do not require ground truth label data to compute these metrics. In LLMs, they might be, so external evaluation metrics examples might be Rouge score and BERT score and so on, where we do not require some ground truth information. Whereas internal evaluation metrics, examples might be, say, groundedness or faithfulness and coherence and so on. Okay. So this is a simple classification of all the evaluation metrics. The point is, external evaluation metrics, because it requires ground truth labels, they can be used only offline mode. Whereas internal evaluation metrics, which do not require ground truth label data, it can also be used in the online mode when the chatbot is already deployed, and hence you cannot expect to have some ground truth data at that time. So these are some of the evaluation metrics, but to have some concrete example, let's focus on this fairly popular evaluation metric for RAG systems called faithfulness, or in some libraries, it's also called groundedness. So before I go to the main question that I asked in the title, how to pick threshold for evaluation metrics, let's just focus on this specific metric and let's see what it is doing, and then we can go to the remaining topic. So what is faithfulness? And there are many versions of this, but here is the original version that Raga's library or Raga's paper proposed. So here what happens is you first assume that you have a query, so user question, and you also have some context, that is the similar vectors from your RAG system. And then you also have answer. Okay, so you have this triplet, but in faithfulness, all you are interested in knowing if the answer, the final answer, is actually grounded to the context that the RAG system has retrieved. Okay, that's the question. Has the answer that LLM gave eventually, is the answer grounded to the context? That's what this faithfulness or groundedness is measuring. And how do we measure this? And this was a very clever idea from Ragas. So this method says that let's use another LLM or LLM as a judge. What it does is it asks this new LLM to create some statements or some claims from the answer that you have from LLM. Okay, so this prompt is essentially just asking to create some claims or statements from the given answer. And then it asks again the same LLM to see if these claims can be verified from just the context that is given. Okay, so you first generate these claims from the given answer and see how many of these claims can be verified using the given context. If 8 out of 10 claims can be verified using the given context, then the faithfulness for that particular question answer context triplet is 0.8. Okay. So faithfulness eventually is the number of verified sentences divided by total number of sentences in the answer. Okay. I'm not defending or defending this method blanketly. All I'm saying is that this is one of the examples of groundedness or faithfulness computation. And of course, there are some limitations here. Let's see some examples so that we understand how we are computing this faithfulness or groundedness. So let's say your question, the original question from the user was, what is the capital of France? The context, or in other words, the similar vectors from the internal documentation tell you that this is the context that the answer should come from. The context is the capital of France is Paris. Paris is known for its culture, history, and landmark, such as the Eiffel Tower. And the answer that LLM eventually gave was the capital of France is Paris. It is a large city with significant cultural heritage. So now, what does this Ragas methodology to compute faithfulness does on this example? So it will first take this answer and it will generate some 3 claims or 3 statements. And this 3 is again a hyperparameter. You can also ask it to generate 10 claims or statements or even 100 statements. So in this example, 3 claims are generated. Paris is the capital of France. Paris is a city with rich cultural heritage, and the Eiffel Tower is a landmark in Paris. Now, it goes to the second step, where it is trying to verify if each of these statements can be verifiable from the context. Okay. So the first statement, for example, the capital of France is Paris. Can it be verifiable from the context alone? And the answer is yes. The second statement, this Paris is a city with a rich cultural heritage. Is it verifiable here? And yes, it can be verified from the context. And similarly, the third one, the Eiffel Tower is a landmark in Paris. Yes, it is also given in the context. So because all 3 statements can be verified using the context, the groundedness score here is 1, 3 or 3. This is just an example. You can play with this library and keep asking different questions and put different contexts and see how it goes. And there are, of course, some limitations. For example, if the final answer is just a number. For example, you ask LLM a question like, what is the meaning of life? And then there is some context for that. And then the answer is obviously 42. Once you have this answer in number, you go to this Ragas library and ask to generate some claims. What claims will it generate from just number 42? Then you have infinitely many possibilities to generate claims or statements from just a number. So that method will not work well there. There are some other remedies for that, but let's leave it at that, there, and let's move on. So now we go to some experiments. So I wanted to do some experiments with some existing implementations of this faithfulness. So I picked 3 libraries. One was Ragas, another one was DeepEval, and the third one was Uptrain. And what was the data? I used publicly available data, not internal data. So fortunately, there is this data set called HaluBench, or hallucination benchmark. It contains some 15,000 samples from many different domains, finance and medical and many other domains. And so what it has is, it has 15,000 question, answer, and context triplet. Not only that, but it also has some human annotated labels. So it says hallucinated or not for each of these 15,000 samples. Okay, so you can just imagine a table where you have 4 columns. One is question, second one is answer, third one is context, and the fourth one is this binary variable hallucinated or not, or fail or pass. Okay, so once we have this data, I asked each of these libraries to compute faithfulness score according to its implementation. And here are the results. So the faithfulness score is on the x-axis, and on the y-axis it's as a frequency. And then I'm also doing this color coding where if the ground truth label is pass, then I put orange, and if the ground truth label is fail, then I put blue. So ideally, if the faithfulness score is completely aligned to the human annotation, then all the fail labels, so all the data points with fail label should be here on the near 0. And near 0, all data points with faithfulness from Ragas should also be 0. Right? 0 meaning completely hallucinated. Okay, so those data points with 0 faithfulness score, those data points which are fail label, they should all be concentrated here on 0. And similarly, all data points with pass label should be concentrating on 1. But I'm also seeing all these peaks in between. Okay, so, and similarly for other libraries as well. So it's not ideal. I was expecting that it will have very clean, only 2 peaks, one at 0 and the other at 1. But as you can see, there are all this mixture of labels as well. So sometimes label pass is given 0 hallucination, 0 faithfulness score by Ragas. So Ragas is saying that it's completely hallucinated, but human is saying that it is not hallucinated, and vice versa. So now the question is, how do you pick the threshold? before deploying this model, or before deploying this faithfulness score in production? Should you pick, I don't know, 0.7 as a threshold, or should you pick 0.85 for ragas, or some other number? What should be your threshold? And that's the question I'm after in this talk. So here is what I've been thinking, and in a few steps process, this is how I would pick a threshold. So first step is we need to make sure that the risks of this specific application that we are deploying are already identified and even better quantified, and that too for specific evaluation metric. So I want to make sure that the stakeholder or even the modeler knows what the risks are when they deploy this model in production and deploy this specific evaluation model or evaluation metric in production. And there might be many different risks, for example, legal risks or compliance risks, regulatory, reputational, financial, and so on. So ideally, we might want to understand all the risks and even better quantify all these risks. So how can we compute this risk? Maybe internally, we might want to have some sort of risk rating methodology for each AI application or any other method that you can think of. Okay. So that's one first step. The second step is I would also try to identify the risk tolerance of the stakeholder. So let's say the stakeholder is some head of the end business unit who is responsible for this specific chatbot and the application that goes with the chatbot. So I would try to make sure that this particular stakeholder knows all the risks, and I would try to devise some sort of methodology to identify the risk tolerance of this individual. So, and how do I measure this risk tolerance, and more specifically AI risk tolerance, is again a very complex subject. I have put some ideas on this in my paper. I'm in no way claiming that I have devised any specific method to measure some individual's AI risk tolerance for a particular application. But what I'm doing is I'm taking inspiration from financial advice business, where if an individual investor like you and me goes to a financial advisor, before putting our hard-earned money into the market, the financial advisor might want to start by measuring our risk tolerance. And maybe in the simplest method, they might put us in high, moderate, or low risk appetite bins, or maybe very conservative, moderate, aggressive, very aggressive, those kind of bins. Whatever the method they use, they might want to first identify some risk tolerance of this individual. And it is very well studied topic, all the way from Kahneman and Tversky in prospect theory. So I'm talking about financial risk tolerance. I would, in theory, do something similar to measure the stakeholders' AI risk tolerance. I haven't thought too much into it. I'm not a behavioral science person per se from my background, but I'm extremely interested in that topic. Anyway, so eventually I want some sort of AI risk tolerance of this individual or the stakeholder. And then finally, before going to the next step, I want to map this risk tolerance that I measured into confidence level score. So all that I kind of rambled in the last 3-4 minutes is to lead to this particular statement for eventually the modeler. So I want some sort of statement that is mapped from this AI risk tolerance and all the exercise that I mentioned in the previous two steps. For example, only 5% of hallucination is accepted for a specific application for moderate risk tolerance. And hence the required confidence level is 95%. Okay, so I want to get to this particular statement eventually. I would leave the methodology and the behavioral science aspect of it aside for the moment. I'm not an expert on that at all. I'm just interested in that topic, but as a spectator. But eventually, as a modeler, I want this kind of statement. I want the confidence level number so that I can move on with my next steps. So let's assume that I have this number, say 95%. Once I have that, then I can do, I'm in business. So then my next job is to prepare some ground truth data. And by ground truth data, I mean, based on my internal documents on which I want to prepare my RAG system, I want to create question, context, answer data, and also some labels from human annotators. And I can create this data in many different ways, maybe just manually asking some interns to do that. Or maybe I can also rely on some another LLM to do synthetic data generation. So ask LLM to create question, context, answer triplets from the available documents and so on. There are many different ways to create this data. Eventually, the human will label this as pass or fail or hallucinated or not and so on. So that's what I'm looking for. I want some ground truth data. Okay, so once I have ground truth data, the third step to determine the actual threshold now for a given metric, in this particular case, faithfulness, what I would do is take this ground truth data, which are labeled, by the way, and then compute the actual faithfulness score on this ground truth data for each of the data points using my chosen library, for example, RAGAS or TPWell. Okay, so now I have two columns. One is the human annotation for each data point from the ground truth data set, which says if this particular data point is hallucinated or not. And the second column is a numerical column in this case, which has the faithfulness score for each of the data points as computed by your chosen library, for example, RAGAS. So I have two columns. That's all I need for picking the threshold now. And then I can start doing all this traditional statistics, or even I can go for more advanced techniques. But just to start with, because I have this confidence level, say 95%, the confidence interval for faithfulness might be, say, the mean of the faithfulness score column plus or minus z-score for the given percentage confidence that you see from that famous statistics table times standard deviation of the faithfulness score. Okay, so that's one of the ways I can pick a threshold. That's the simplest way. So again, to pick threshold in the simplest possible way, once you have this two column data, you just compute the mean of the faithfulness score and plus or minus z-score for the given percentage confidence and times standard deviation of the faithfulness score. Okay, so and here this z-score corresponds to your risk appetite. If it is 90%, 95, 98, and so on. So that's the simplest method I can think of. And to be more conservative, I would probably take mean minus z-score, not plus. Anyway, so that's one method. And to be even more precise, I would do this cross-validation. So I would take first four folds from this 2-column data, and then compute this threshold and see if this threshold was picking the right hallucinated and not hallucinated data in the 5th holdout fold, and do it for five times, and I have a better understanding on how this threshold is doing. Okay. So essentially what I'm doing is nothing but traditional machine learning. I have some ground truth data, and I have some method, in this case very simple method to pick threshold, and I'm testing this in cross-validation fashion. But I can even do better. So instead of this z-score, I can use conformal prediction, for example, to get all these confidence levels. Because here, so far we are assuming that the faithfulness score will just follow some normal distribution, and hence all the z-score and stuff is valid. But conformal prediction is distribution assumption free method. So maybe a better way is to use conformal prediction for confidence levels, and then eventually picking the threshold. And you can do so many other methods. For example, in the paper we have discussed kernel density estimation, and you can, because you have this 2-column data, faithfulness score, and the actual ground truth human annotated labels, you can fit a logistic regression between them. So predicting the human annotation using faithfulness score, using logistic regression, and then compute AOC, ROC, and pick threshold based on that, based on your confidence level. We also tried GAMS instead of logistic regression, and so on. So I would not go into detail on these results, except just putting some picture. So here is an example on picking a threshold. So this blue is confidence level corresponding to 99% confidence level. And then red is the threshold corresponding to 80% confidence level. So this is how this is probably one of the first paper, or maybe the first paper, which is discussing how to pick threshold for LLM evaluation metrics. I just wanted to start some discussion on this topic in the industry. I'm sure people will eventually come up with some better methods. But I hope I give some intuition on how to pick thresholds. So I'll flash the conclusion slide, and I'll open up for questions.
Thank you so much, Paresh. This was fascinating. I mean, it's a lot of information, obviously. It needs to be processed, and I did share the paper link. It definitely is some really cool work, and I'd love to kind of dig deep into kind of understanding how to go about it. Now, let me kind of try to summarize some of the questions in here, and then I have some of my questions on my own. So one question Huang Li was asking was, do you consider human annotated data as high quality or ground truth? Is there any subjective reasons on
that topic is also heavily discussed in psychology, and two human annotators might not agree many times. So then you might want to go for this Cohen-Kappas and Krippendorf alpha, and I'm forgetting those specific names, but there are all these measures to compute the overlap between raters. So of course we can do better than that. There is no way we can remove human biases from this.
Right. And kind of follow on, probably something to link with Shashank had a comment. I think human uncertainty contributes to the noise to this. Perhaps inter-rater reliability can be used to weigh the comparison.
Yeah. That's what I was referring to.
Okay, perfect. So maybe I'll start with like a higher level question. I know some of these terminologies are probably, if you're trained on LLMs and trained on kind of, looking at evaluation metrics, it becomes, if you come from a statistics background, you have a lot of prior art, if you will, to kind of, build upon as you're kind of building out these newer metrics, right? How do you see the role of development and, in terms of the life cycle of a model development, how do we build in this as a practice, as a discipline in the process of design and development? And how do we kind of see this kind of dovetailing into model validation as we go about building out things? Because as you know, uh, developers have different criteria as you're kind of evaluating different metrics versus validators who have a different perspective, as in you have to first of all think about like the connection to the business use case, and sometimes it may not even be feasible to look at some of the technical aspects considering the knowledge gap plus also the amount of assumptions you need to make as you're kind of evaluating it. So in terms of the life cycle, how do you kind of see this into putting into the framework?
So in this particular paper, I was just focusing on very small segment of the whole model life cycle, which is as the evaluation matrix.
Right.
Interestingly, when I was writing this paper, Agus was also writing paper on this RAG overall model validation approach. So I think he's also thinking along the same line. We are of course a bit far from coming up with a complete validation approach for LLMs.
Mhm.
On the other hand, it's still yet another machine learning technique. Many of these can be viewed as classification task or regression task, sometimes unsupervised learning. So if we have some best practice for traditional machine learning models,
Mhm.
we might be able to adapt to the whole best practices to this LLMs as well.
Okay. And
That's what I'm doing, to be honest here. So I'm just thinking from the machine learning side. That's why I'm coming up with all this cross validation and check threshold for some folds, and then test on the holdout fold.
absolutely, absolutely. And you mentioned a couple of benchmarks in here. So I know you can't specifically talk about what's being done within BlackRock, but are there best practices? So if someone's kind of, let's say taking a very simple use case, financial statements, if you will. So, or maybe even building a chatbot. So what are like the three metrics they should be kind of, focusing on if they are using a RAG? And how can you dovetail that into some of the metrics you mentioned? I mean, obviously you talked about the internal and the external aspect. So is there something you could kind of provide as guidance, as possibilities for here are like some of the things which has kind of worked for us or is more in line with some of the problems we see in financial services?
So the whole area is still evolving. I won't talk about BlackRock specifically, but in general, the definition of model
Mhm.
itself is now under question.
Right.
What
Yeah.
is the foundation model, the model that you need to validate and monitor, or it's a downstream model that you need to monitor and validate? And the third type of model here, as I see it, is evaluation matrix,
Right.
which is very unique situation, which probably we did not have previously in finance. All this RMSE and R square, they are just some simple functions. You put some numbers in and get output in one number. There was no statistics going on. Any day you put exactly the same number and you get exactly the same number out. Here, LLM as a judge is a whole different game, where now the evaluation metric itself may be classified as a model.
Mhm.
So So that's what my thinking process is. What are we governing?
Right,
Uh,
right. Yeah.
Are we
So it kind
responsible for the foundation model or only downstream model or both?
Yeah, in some ways, it kind of leads to, I think, two comments. I think Andrew had talked about, and also Satyaki is bringing about. Most of the times you can't evaluate the LLM, but how can we measure the LLM use cases such as RAG implementation? So we're talking now as a system rather than just the model, right?
Yeah.
And how do you isolate the effect of the LLM in the RAG implementation, um, specifically the retrieval and the augmentation part of it? Um,
Yeah. So um, I don't have any specific answer to that question. How to just decompose all the effects of different
Absolutely.
components.
Yeah.
Maybe SHAP values. Maybe SHAP using SHAP because it's also computing the fair contribution of
mhm.
each of the components or each of the agents or each of the features to come to this particular conclusion.
So you're
Maybe
talking about, like, what if you line up all the elements which goes into this AI system and then look at contributions of individual aspects and trying to
yeah,
quantify of it?
yeah. It's again a high level vague idea. I don't know what exactly the components I would use in SHAP values, but whenever someone asks me about decomposing contribution of a big system, I always think of SHAP values. That's my first thought always.
Okay, okay. That's an interesting paradigm. Kind of, I'm not sure how much you can quantify, but in some ways you could at least try and bucket it like like the high-low, moderate kind of, classification you put together. So, what aspects are highly contributing to the outcome, something like that, and then see if you can connect those. There are a couple of other questions. I'll try to see, if I can summarize that with the few minutes we have. One, I think Andrew had a couple of comments about, the EU AI Act and, AI models being a part of the AI system, and also risk appetites. Andrew, I don't think had a specific question, but you did add to the discussion on the chat. Now, Michelle had a question about, like, did you have some conformal prediction results you could share? Also, did you try using natural language inference as an evaluation metric, for which LLMs are pretty accurate?
So we do have conformal prediction results in the paper. I don't have that in the slide.
Okay,
I wanted to be at slightly higher level,
right. Okay.
but
Michelle, I shared the link to the paper, so please take a look at it. And obviously, you can contact uh,
absolutely, yeah.
the Dagesh to get additional questions clarified. I think Kash had a question about, have you explored using SLMs for validating LLMs, or LLMs validating LLMs? Or is it more reasonable?
So in even in this faithfulness from ragas, we can use some another small language model
Mhm.
to generate these claims and then verify if they came from the context or not.
Right. Uh-huh.
So in theory, yes, absolutely, it can be done. You just need to switch from whatever the LLM ragas library is using with this your favorite small language model, including DeepSeek now.
Okay. Yeah. So, we're gonna cut down the verification cost by 90% by putting it.
Yeah.
Um, I know we are kind of running out of time. I know there are a lot of interesting questions coming up, and Huang had a comment, but also a question like, you mentioned logistic regression, Raga scores against human annotation. Do you have any examples you could share, and what were the findings?
Yeah, so again, all these things are already in my paper, but for this particular example, if I remember it correctly, it was some 0.80 percentage accuracy for this binary classification and some precision, I recall an F1 score. So in other words, faithfulness score was able to predict only 80% of the
Mhm.
human labels.
Okay,
And
interesting.
hence you have to pick a threshold on the probability, right? So when I say 80%, I'm assuming that the probability threshold is 0.5. But if I change that, does it increase the human annotation accuracy? Does it increase accuracy? And at which point it increase the accuracy by your desired value?
Mhm.
That will be a better threshold for
Okay.
probability.
Interesting. And again, this is a fascinating body of work, Dinesh. I'm really impressed that you put all these things together. As I mentioned, I'm going to share the slides to all the people who are registered, and also share the link to the paper. I also put a link to the paper in the webinar chat. Before I can let you go, I do have one last question. 6 months from now, where do you see this whole R1 DeepSeek discussion going, and how do you see financial companies adopt? I already saw, Microsoft and Amazon have already put together like processes on how you can stage your own DeepSeek model on their cloud, and you can start using it. So both in the context of validation, but also benchmarking, and also potential distillation and extending the open source model. Where do you see, if you had a crystal ball, you could potentially use?
Yeah, I've stopped predicting things nowadays in AI, but even DeepSeek guys put this another model out, right? Janus,
Right.
which is for multimodal text to image model.
Yep.
So from the end user point of view, probably it's not that big of a difference as long as I can switch between models, the foundation models. So if I'm currently using uh, Claude or Llama 3 or GPT, and then I want to now switch to DeepSeek, all I, in theory, need to do is just change the API.
Right.
So of course, it's not as simple as that, because maybe the answer might be different and I need to recalibrate my downstream model a bit. But from the engineering point of view, that's all it might require. So from the end user point of view, or from the end developer point of view, it might not be that much of a difference.
Mhm. Is that
But
so? I mean, maybe I'm kind of, over engineering this or overthinking this. I was kind of thinking, many times when we think about like chunking strategies in RAG, and trying to optimize the token back and forth, optimizing costs. Now, if your cost goes down 90%, you could start experimenting with bigger context windows, more agentic trial and errors, and maybe building upon your prior answer and refining the answer and multiple round trips to a large language model, considering that you're not expending the same amount of tokens or expending the same amount of costs. So my thought was, there could potentially be other design patterns which could potentially evolve, wherein the cost is not a major criteria. I mean, like most of the times, like we go for RAG because we want to reduce the context windows. We want to focus on like bringing the chunks which potentially has the answer, and then kind of package it rather than just uploading a whole PDF file. I mean, ideally, if I had a PDF file and it had an answer, and there was no question of a cost, I would just upload the PDF file and hope that the answer could potentially be retrieved from that, because I know that that particular piece has that information. And the chunking optimization, potentially overlapping windows, and kind of building the metadata around it, and all the engineering we do is to kind of optimize on the cost. So I was kind of thinking, is that going to be an avenue wherein we can potentially explore more on the software side, design patterns to enhance the process itself? That way we could now start comparing, well, this used to be my answer, but now with more engineering and not having to worry about cost, we could potentially get better answers for the questions we're asking.
yeah,
Right.
absolutely. So I was just referring to the ease of switch from one
Right.
model to another.
Yeah.
But absolutely, I mean, we can also do, hopefully, fine tuning more easily. Right now, with all these big models, we don't have enough compute to do fine tuning for our own internal data, which hopefully will be possible with this all these developments now.
Absolutely. Um, I'd love to continue the discussion, Dagash, but I know it's 1:04, and I know you're a busy man. and all the people on this call are also busy people. So we are kind of, roping in all the experts in this area of model risk and financial services to, run this amazing talk. Thank you so much for sharing your, research and also all the work you've been doing. I'd love to continue the discussion, but for people who are online, we will share the slides and the paper, and you can definitely reach out to Dagash. He's on LinkedIn and he is very accessible. I really appreciate you making the time, and also all the attendees for making the time for this session. And please stay tuned for future sessions. We'll make an announcement on LinkedIn, and if you are signed up for our mailing list, you'll get a notification too for future sessions. With that, we will conclude today's session, and thank you again, Dagash. It was a
Of
pleasure.
course, thanks very much for having me.
Have a wonderful, warm evening.
You too.
Take care.
Thanks. Bye.